Alright, let's get started practicing subtracting decimals. Subtracting decimals is very similar to adding decimals, just like subtracting fractions is very similar to adding fractions. The steps are almost exactly the same. First, you have to make sure that your decimal points are lined up. And once your decimal points are lined up, you just subtract like normal. Wherever there's an open space, you can use 0 as a placeholder because 0 doesn't change the value. Alright, we have to do 2 minus 0, which is 2. You cannot do 1 minus 3, so we will have to borrow. So this becomes a 3. And now we have 11. We can do 11 minus 3, which is 8. And then 3 minus 2 is 1. Just like for adding, the last step of subtracting decimals is to bring down the decimal point. So our final answer becomes 1.82. Let's look at a second example here with slightly larger numbers. In our first example, we had to use a 0 placeholder in our bottom decimal. We could also use a 0 placeholder in our top decimal. It just means that when we go to do 0 minus 9, we're going to have to end up borrowing. So this 0 becomes a 10, and 10 minus 9 is 1. 0 minus 0 is 0. 2 minus 1 is 1. 7 minus 7 is 0. And lastly, 1 minus nothing leaves us with 1. Alright, last step is to bring down the decimal point. And so our final answer becomes 10.0101. Alright, let's look at one more example here with larger numbers. We do need to use a 0 placeholder value. And because we can't do 0 minus 2, we will have to borrow. So 6 becomes 5 and our 0 becomes 10. 10 minus 2 is 8. 5 minus 5 is 0. 8 minus 3 is 5. 5 minus 4 is 1. 4 minus 1 is 3. We cannot do 0 minus 2, so we have to borrow, leaving us with 10 minus 2, which is 8. Again, our last step is to bring down the decimal point, and our final answer becomes 83.1508. Alright, I have two problems that I want you to try on your own. Pause the video until you have all your work completed, and then press play to check your answer. Alright, let's look at this first problem here. We have 3 decimal place values after both of our decimals and both problems here, so we don't have to add any 0 placeholders, so we can just go right to subtracting. We can't do 2 minus 4, so we're going to have to borrow. So when we go to do 12 minus 4, we'll get 8. 8 minus 2 is 6. Again, we can't do 5 minus 8, so we're going to have to borrow. This becomes a 15. 15 minus 8 is 7. Can't do 1 minus 6, so we're going to have to borrow again. And this is a 11 now. 11 minus 6 is 5. And lastly, 2 minus nothing is 2. Last step, bring down that decimal point, and our final answer becomes 25.768. Alright, let's look at your other problem. This one we do have to use a 0 placeholder. And since we can't do 0 minus 7, we have to borrow. 10 minus 7 is 3. 2 minus 2 is 0. We cannot do 4 minus 9, so we'll borrow again. 14 minus 9 is 5. And then on 0 minus nothing, still 0. 1 minus nothing, still 1. Last step, bring down that decimal point. And our final answer is 105.03. You'll notice on all these problems, I've made the decimal point very, very large and dark and noticeable. Go back and check your answers and make sure you can clearly see where the decimal is, because it'd be silly to miss a point on one of your problems because you can't see where the decimal point is. All right, let's do some fraction review. Pause the video while you try to remember the steps for subtracting fractions and press play when you are ready to check your answer. Alright, subtracting fractions is very, very similar to adding fractions. First you need a common denominator, then you subtract the numerators, and last you simplify. So in our first problem here, we do have a common denominator. Our common denominator is 7. So we don't have to find one. We can just go right to step 2, which is subtracting our numerators. 5 minus 3 is 2. And we keep our common denominator as 7. If you're still confused about why this common denominator never changes, draw yourself a little picture. If you have a pizza that's cut into 7 equal parts, and we start with 5, so 1, 2, 3, 4, 5, and then we take away 2 or 3, we're left with 2 pieces left. But we still have a pizza that's cut into 7 parts, which, remember, that's what our denominator tells us. So our denominator never changes because our pizza is always going to be cut in that same amount of pieces. All right, let's look at our second example here. We do not have a common denominator in this fraction problem, so we have to go ahead and find one. The way we go about that is by multiplying by the opposite. So our new common denominator becomes 10 times 3, or 30. All right, but our golden rule, whatever we do to the bottom, we have to do to the top. So if I multiply by 3 on the denominator, I have to multiply by 3 on the numerator. If I multiply by 10 on the denominator here, I have to multiply by 10 on the numerator. 7 times 3 is 21. 1 times 10 is 10. Our last step is to subtract our numerators. 21 minus 10 leaves you with 11. Over 30. Again, our denominator never changes. Last step is we have to check and make sure. Can we simplify this? And we end up, we cannot, because 11 is a prime number and 30 is not divisible by 11.